It's really amazing that the place we're walking right now was once swampland, part of the ocean. And it was made into property over a series of centuries when people dumped ground, they dumped earth, they dumped garbage, ashes, leftover material from the fires that raged in Lower Manhattan, really anything they could to make new land.
Building on garbage and other material has helped Manhattan expand over 400 years. But Sandy's powerful storm surge temporarily took the water line right back to where it started.
I've just walked up from what the high water mark was during Sandy, and you can still see trucks on Pearl Street cleaning up garbage and pumping water out of basements. It's no coincidence that those trucks are down there because Pearl Street was, until the 17th century, the original shoreline of Manhattan. In fact, Pearl Street is named after the oysters that lay in the shallow areas near the shoreline.
Oceanographer Simon Boxall believes that messing with nature can have disastrous consequences.
As we've been pushed more and more in terms of space in our cities, and many cities are on the coastlines, so we sort of extended out into the floodplains, into the areas that nature has traditionally used to protect the land itself against storm surges, against hurricanes. So we're now living in the area that was the buffer zone, and that's the big problem. It's made worse in the case of the eastern seaboard because it's difficult to put up sea defenses.
All along the East Coast, beachfront properties are directly in the path of potentially dangerous storms.
It's desirable to have your property overlooking the coast, overlooking the water. But if you build along the coast, if you build in floodplains, if you build in reclaimed land, then you are at much, much greater risk. And you're always going to be exposed, regardless of what sea defences you put up, to the possibility of nature eventually taking that land back. But it's the frequency in which these things are occurring that we need to start really worrying about. And I think Sandy's been a big wake-up call for people in New York and along the eastern seaboard.
This is unbelievable, man. Unbelievable.
We often take things from nature, like the land on our coasts. Nature is very good at taking that back, and it's done it in this case with Hurricane Sandy.
How did Hurricane Sandy turn into a superstorm of epic proportions? A storm that brought chaos to the Caribbean, then headed for North America.
You prepare for the worst and hope for the best. That's what you do.
And brought winds that toppled thousands of trees.
We've never seen anything like this.
Nope.
The waves are triple the size of a human being.
Sandy's storm surge pounded U.S. shores, altered the shape of her beaches.
I grew up here. I've been here since I was born. This is absolutely sickening.
And inundated her suburbs and towns with billions of gallons of ocean water. She caused fires that raged through people's homes and stretched New York's emergency services to their limits. Just 7 days earlier, off the coast of South America, the storm was beginning to form. In this region, the warm temperatures of the Caribbean Sea allow trillions of energy-bearing water droplets to evaporate, creating denser cloud systems, which can start to spin. As its winds hit 74 miles an hour or more, Sandy is branded a hurricane. The storm was a deadly threat, taking 71 lives and devastating Caribbean islands on its way. It was important to learn as much as possible about it, so the National Hurricane Center dispatched its planes on hazardous missions.
We have a crew that will be leaving today, and they'll be flying back to back.
We have 2 planes, so one plane would fly, and then the next 12 hours, the next one would fly. And we kept doing this until it made landfall.
So hopefully the data that we'll collect based on this flight pattern, where we're going to drop all these different drop zones, will help to narrow down that intensity and the track of Sandy. When we're flying on the P-3 Hurricane Hunter aircraft, it's essentially a flying laboratory. We are collecting drop zone data, which are these drones that we deploy from the aircraft.
The probe parachutes down, measuring the hurricane's temperature, humidity, and pressure, as well as wind speeds and direction.
We knew that the data collected was going to help those emergency managers know whether to evacuate the people on the New Jersey, New York coast for Hurricane Sandy.
The Hurricane Center's meteorologists were shocked by the data. Sandy was now in a different league. It was on course to create a larger system with frightening destructive potential.
The data collected from the P-3 aircraft showed that the wind field was so large, it expanded more so than what we've ever seen in the last decade or so.
Normal hurricanes, they're pretty small and their wind field is pretty small, so it doesn't impact a very large area.
Tropical systems are very concentrated. The winds are very strong, but it's very concentrated. So this dilution of the storm spreads that grief over a much larger domain.
Its size actually made it very devastating.
Meteorologists began to realize that Sandy was destined to be among the largest hurricanes ever to form in the Atlantic Basin. Andrew, 180 miles in diameter. Katrina, even bigger. Irene, Sandy, the mother of them all.
This was around about 1,000 miles across, and that is huge. That's a superstorm.
Hurricanes traveling off the eastern seaboard usually turn east and fade out over the North Atlantic. But with a weather front over Greenland and a low-pressure system over the U.S., Sandy took a different course.
The other unusual thing about Sandy is that it didn't recurve out into the Atlantic, which is what hurricanes normally do when they get up to the latitude of New York or New Jersey. Sandy recurved inward.
If we have winds that are out of the southwest, that'll tend to recurve the system to the north. If we have winds that are of a different direction, that will tend to drive the system in that direction.
Aware of Sandy's landward trajectory, authorities called for evacuation from its predicted path. They feared that Sandy would bring in a storm surge. Approaching land, a hurricane's wind drives water toward the shore, wave after wave, hammering coastline structures and flooding city streets.
Those waves aren't just created locally, they've been created as the storms moved across the Atlantic. So they're moving in, and so all of a sudden we get 14, 15, 16 feet of water.
A cubic yard of water weighs nearly a ton. Sandy's storm surge dumps 500 million tons of Atlantic water on New York City and the Jersey Shore. The moon provides the final piece of Sandy's lethal jigsaw. The force of the moon's gravity pulls on Earth's water, lifting the surface fractionally towards itself. Oceans bulge towards the moon to generate 2 oceanic tides per day. At times of a full moon, its gravity can align with the sun to produce particularly high tides. Superstorm Sandy made landfall just when a full moon was brightening the sky.
That full moon, that high water, gave an extra 6 feet onto the sea level. Had the hurricane hit during a half moon, where we don't get the very high tides or at low water, we wouldn't have seen the amount of flooding on the eastern seaboard, inland, into the cities, into the suburbs.
Sandy picked the worst possible time to hit. She hit an astronomical high tide. Sea level tides are going to be higher than they would normally. At the same time, because of the driving wind, 14-foot storm surges made worse by this high tide.
On October 29, 2012, the coast met Sandy's full moon high tide storm surge. A vast wall of water rushed towards the shore, powered by the hurricane's 90-mile-an-hour winds.
Water is a very dense fluid, much more dense than air. Sandy had immense impact with regard to water damage due to the strength of the winds, and that pushed water into the lower parts of Manhattan. You just had a tremendous amount of water funneling into a small area.
Cut off from the energy source of a warm ocean, Sandy very slowly lost its strength. But had this been the perfect storm?
What makes it perfect is just that all the right ingredients came together for it to have a high impact.
This really was a superstorm. I mean, you have the massive storm surge, the winds, power lines down, flooding rains, and believe it or not, in October, some places in West Virginia, 36 inches of snow, 3 feet of snow. And far away in the Great Lakes, 1,000 miles away, there were surfers riding 20-foot waves. Sandy was that massive. The entire east coast of the United States, as far back as Chicago and the Great Lakes, impacted by this storm.
Extreme weather is affecting every part of the globe. In 2012, Russian agriculture suffers its second drought in 2 years. Great Britain is deluged by record-breaking summer rainfall. And Venice continues to flirt with the sea. In the U.S., destructive tornadoes are rampant. And more than 9 million acres burn in wildfires sparked by tinderbox conditions. Climate change appears to be real. Average temperatures have risen more than 1 degree over the past 100 years. But can extreme weather events like Superstorm Sandy be linked directly to a changing climate?
We're still trying to understand the effects of climate change, and whether or not we'll see more storms like Sandy is still unknown.
Coming from a scientist background, we have to really look at it objectively. If you start saying that the rare event is becoming the common event, that to me is good evidence for something is changing. Now, that needs to be quantitatively done, not done in an ad hoc nature. If someone can show that, then I'm on board with believing more of the change aspects.
Global warming means that there's more energy in our atmosphere, there's more energy in our oceans, and this energy is seen in terms of storms, and that energy means we get more extremes. Unseasonal weather, our seasons are changing. More hurricanes, heavier winds, more tropical storms. And it's this pattern of events